Welcome students. Today we are going to see about association rule mining. It was in the year 1990 when computer researchers Rakesh Agarwal, Thomas and Arun Swami created an algorithm based way to discover interactions between products using point of sale scheme. The ideas behind association regulations can be traced back previously. The researchers were able to find connections between distinct items by applying the algorithms to supermarkets. Association rule mining is a method aimed at finding frequent trends, correlations, associations or causal constructions from information sets discovered in different types of databases like relational databases, transactional databases and other types of information repositories. The main use of this particular association rule mining is mainly to predict the occurrence of a specific item based on the occurrence of other items in the transactions. Because of a set of operations, association rule mining seeks to discover the patterns that allow us to predict an event. Association rule mining is the data mining method of discovering patterns between sets of things that can regulate connections and causal objects. Association rule mining is one of the ways to find patterns in data. It finds the following features. Features are nothing but the dimensions which occurs together or features which are correlated together. What does the value of one feature tell us about the value of another feature? For example, people who buy diapers are likely to buy baby powders. Or we can rephrase the statement by saying, if people buy diaper, then they buy baby powder. This is called if-then rule in association rule mining. This does not necessarily mean that if people buy baby powder, they buy diaper. In general, we can say that if condition A tends to B, it does not necessarily mean that B tends to A. Watch the directionality carefully in the above statement. When to use association rules? We can use association rules in any kind of data set where features take any of the two values, that is either 0 or 1. Some examples of association rule mining are market basket analysis, which is a very popular application of association rules. People who visit web page X are likely to visit web page Y is another example. People who have age groups between 30 and 40 and income more than 1000 rupees are likely to own home. The main applications of association rule mining are market basket analysis. This is the most typical example of association mining. Data is collected using barcode scanners in most supermarkets. This database is known as market basket database, which consists of a large number of records on past transactions. A single record lists all the items bought by a customer in one sale. Knowing which groups are inclined towards which set of items gives these shops the freedom to adjust the store layout and the store catalog to place the optimally concerning one another. Example is Reliance. The second application of association rule mining is medical diagnosis. Association rules in medical diagnosis can be useful for assisting physicians for curing patients. Diagnosis is not an easy process and has a scope of errors, which may result in unreliable end results. Using relational association rule mining, we can identify the probability of the occurrence of illness concerning various factors and symptoms. Further, using learning techniques, this interface can be extended by adding new symptoms and defining relationships between the new signs and the corresponding diseases. The third application is census data. Every government has tons of census data. This data can be used to plan efficient public services like education, health, transport, as well as help public businesses for setting up new factories, shopping malls, and even marketing particular products. This application of association rule mining and data mining has immense potential in supporting sound public policy and bringing forth an efficient functioning of a democratic society. The fourth important application is protein sequence. Proteins are sequences which are made up of 20 types of amino acids. Each protein bears a unique three-dimensional structure which depends on the sequence of these amino acids. A slight change in the sequence can cause a change in structure which might change the functioning of the protein. This dependency of the protein functioning on its amino acid sequence has been a subject of great research. Earlier, it was thought that these sequences are random, but now it's believed that they are not random. How association rules work? This is the question in many of our minds. Here is the answer for it. Basically, association rule mining involves using machine learning models to analyze trends or co-occurrence data in a database. It describes frequent items, if-then connections called association rules. These are two components to an association rule, a precedent which is represented by if and a consequent which is represented by then. A background is an object discovered in the information. An element discovered in combination is a consequence. If-then statements are discovered to be true sometimes. A third metric known as lift can be used to compare trust with anticipated trust. The rules of association are calculated from item sets consisting of two or more items. If rules are constructed from analyzing all possible item sets, so many rules could exist that the rules have little significance. This typically creates what is known as association rules. As I said earlier, association rules are nothing but if-then statements that demonstrate the likelihood of interactions in different kinds of databases between information items within big information sets. Association rule mining has a number of apps and is commonly used to assist in transactional data or medical information sets, discover sales correlation, and in medical diagnosis. In order to select interesting rules from the set of all possible rules, constraints on various measures of significance and interest are used. The best known constraints are minimum thresholds on support and confidence. For example, let us consider X and Y be the item sets, which shows that X implies Y is an association rule and T represents a set of transactions which are done on the given database. In association rule, we are using support and confidence. What is support? This gives the frequency, that is, number of times the item had occurred in the particular data set. If you consider a basket containing 10 items, 5 apples, 3 eggs and 2 pens, then support of any precise item, say apple, can be 5 as mentioned. Likewise, precise value can be calculated by the proportion of number of occurrences to the total number of items in the basket. That is, support for an item apple represent 5 by 8. That is, out of 8 items, 5 items support apple. The next factor related to association rule mining is confidence. This explains how likely Y is purchased when X is purchased. This defines association between two items. For example, when a person buys milk is more likely to buy bread as well or vice versa. This is measured by the proportion of transactions with item X in which item Y also appears. This relationship is expressed as X implies Y, calculated by the proportion of number of transactions in which both X and Y occurs to support a particular item X. The third important factor is called as lift. What is lift? The lift of a rule is the ratio of the observed support to the expected if X and Y were independent. A typical and widely used example of association rules application is market basket analysis. This is explained by a diagram which you can see where these three important factors are represented with the formula. Now we will move to the next concept which is called as association rule algorithms. The most important algorithms are AIS, SETM, a priori, and the later variants are popular algorithms that use association rules. Item sets are produced and counted with the AIS algorithm as it scans the information. In transaction data, the AIS algorithm determines which large item sets contained a transaction, and by extending the large item sets with other items in the transaction data, new candidates items can be created in this way. Also, the SETM algorithm produces candidate item sets as it scans the particular database, but at the end of its scan, this algorithm accounts for the item sets. New candidate item sets are generated in the same way as with the AIS algorithm, but what is the difference? With the candidate item set in a sequential structure, the transaction ID of the receiving transaction is saved in the case of SETM. At the end of the pass, the support count of candidate item sets is created by aggregating the sequential structure. The downside of both the AIS and SETM algorithms is that each one can generate and count many small candidate item sets. Candidate item sets are produced using the a priori algorithm using only the big item sets of the past pass. The prior pass's big item set is joined to create all item sets with a volume that is bigger by 1. Every item set produced with a non-large subset is then removed. The applicants are the remaining item sets. Any subset of a frequent item set is also considered a frequent item set by the a priori algorithm. According to Syed, with this strategy, the algorithm decreases the amount of applicants being considered by investigating only the item sets whose support count exceeds the minimum support count. Uses of association rules in data mining. Association rules are helpful in data mining to analyze and predict customer behavior. In client assessment, market basket analysis, product, clustering, catalog design and store layout, they play a significant role. Programmers use association rules to construct machine learning capable programs. Machine learning is a type of artificial intelligence that seeks to construct programs that are capable of becoming more efficient without explicit programming. What are the examples of association rules in data mining? Here are few. A classical instance of association rule mining relates to a diaper and soft drink connection. The instance, which seems to be fictitious, states that soft drinks is also probable to be bought by males who go to a shop to purchase diapers. Data that might seem like this, for example, you consider a supermarket which has 2 lakh transactions with customers. The purchase of diaper includes about 4,000 transactions, or about 2% of the complete operations. Approximately 5,500 transactions, that is nearly 2.75% involve buying soft drinks. Of these, approximately 3,500 transactions, that is 1.75%, includes both diaper and soft drink purchases. What does this example teach us? This amount should be much smaller based on the percentages. However, a connection between diaper and soft drink is indicated by the fact that about 87.5% of diaper purchases include buying soft drinks. Now we will see in detail the market basket analysis. Market basket analysis is a method of information mining that distributors use to boost revenues by better understanding patterns of client purchase. It includes analyzing big information sets to show product groupings such as purchase history as well as products that are likely to be bought together. Through the introduction of electronic point of sale, which is POS scheme, market basket analysis was helped. The digital documents produced by POS systems made it simpler for apps to process and evaluate big quantities of purchase information compared with handwritten documents held by shop owners. Implementing market basket analysis needs a background in statistics and data science as well as some computer programming algorithmic abilities for students. There are business of the shelf instruments for those without the necessary technical abilities. One such instance is your Microsoft Excel shopping basket analysis instrument, which analyzes transaction data in a table and conducts market basket analysis. A transaction ID must link the product to be evaluated. The shopping basket analysis instruments then generates two types of worksheet. The worksheet shopping basket item groups, which lists frequent bought items together, and the second worksheet is shopping basket rules, which demonstrates how items are linked. For example, product B purchasers are likely to purchase product B, for instance. Types of market basket analysis. There are two types of market basket analysis. Predictive market basket analysis is the first one. This chart considers sequential products bought to determine cross-selling. The second one is differential market basket analysis. This form considers information from distinct shops as well as purchases from distinct groups of customers during distinct times of the day, month or year. If a rule holds in one dimension, like for example consider as store, time period or group of customer, but it does not hold in other dimensions, analysts may determine the factors responsible for the exception. These insights can result in fresh product provides driving greater revenues for the shopkeepers. What are the algorithms that are associated with market basket analysis? Here are the few. Association rules are used in market basket analysis to predict the probability that products will be bought together. The rules of association count the frequency of items that happen together, attempting to discover connections that happen much more frequently than anticipated. AIS, SETM and a priori are algorithms that use association rules. Let us look into a study paper on market basket analysis. The a priori algorithm is frequently quoted by information researchers and is used to define frequent items in the database and then assesses their frequency as the data sets are extended to time sizes. The R rules package is an open source toolkit used by the R programming language for association rule mining. This package promotes the a priori algorithm as well as other mining algorithms, which includes NB miner, Opus miner, R-Keel and R-Sarusless regulations. Examples of market basket analysis is the Amazon website, which uses a well-known market basket analysis instance. Amazon introduces customers with associated products on a product page under the heading frequently purchased together, and customers who have also purchased this particular item also. Market basket analysis also applies to bricks and mortar shops. If assessment showed that magazine purchases often include buying a bookmark, which could be deemed an unexpected combination as the customer did not buy a book, then a range of bookmarks could be placed near the magazine rack by the bookstore. Given a set of transactions, we can find rules that will predict the occurrence of an item based on the occurrences of other items in the transaction. For example, consider a table which consists of the transaction ID and the items. The table shows the following transaction IDs and the item. The column 1 consists of the items bread, milk. The second column consists of bread, diaper, soft drink and egg. Third column consists of milk, diaper, soft drink and an health drink. Fourth column consists of bread, milk, diaper and soft drink. Fifth column consists of the following items: bread, milk, diaper and health drink. Before we start defining the rule, let us first see the basic definitions. What is support count? It is a frequency of occurrence of an item set. For example, consider the item set which consists of milk, bread and diaper. The support count is 2 according to the table. What is a frequent item set? An item set whose support is greater than or equal to minimum support threshold. Association rule and implication expression of the form X implies Y, where X and Y are any two item sets. For example, consider milk diaper implies the purchase of the soft drink. What is meant by rule evaluation metrics? There are few rule evaluation metrics which is used to analyze the performance of association rule mining. The first one is support. Support is nothing but the number of transactions that include items in the set X and set Y parts of the rule as a percentage of the total number of transactions. It is a measure of how frequently the collection of items occur together as a percentage of all transactions. The second important matrix is support, which is represented as sigma X plus Y divided by total. It is interpreted as fraction of transactions that contain both X and Y. The third important matrix is confidence, which is represented by C. It is nothing but the ratio of the number of transactions that includes all items in B as well as the number of transactions that includes all items in A to the number of transactions that include all items in the item set A. The next matrix is confidence, which is represented as X implies Y, which is nothing but sigma support X union Y with divided by support of X. What it is? It is nothing but it is a measure of how often each item in Y appears in transactions that contains items in X also. The next matrix is lift, which is represented by means of L. Lift is nothing but it is represented by a rule, again X implies Y, but it is represented as the confidence of the rule divided by the expected confidence, assuming that the item sets X and Y are independent of each other. The expected confidence is the confidence divided by the frequency of items in Y. The next matrix lift, which is represented as X implies Y, which is equal to confidence of X implies Y divided by the support of Y. Lift value near 1 indicates X and Y almost often appear together as expected. If it is greater than 1, it means they appear together. More than 1 means they appear less than expected. Greater lift values indicate stronger association. Now let us see, for example, consider a set which consists of sigma of milk, diaper and the soft drink, which represents the transactions, that is divided by the transaction which is equal to 2 divided by 5, where 2 represent the total occurrence of all these items, milk, diaper and soft drinks, with respect to the total transaction, and the value is 0.4. Now let us consider confidence. What is confidence? For a given example, let us consider the confidence of an item set milk, diaper and Sprite. Let us consider the confidence of the item set milk, diaper and soft drink divided by the occurrence of the items milk and diaper. The confidence is now represented as 2 divided by 3, which is equal to 0.67. The next matrix is lift, which is equal to support of the item set milk, diaper and soft drinks divided by support of milk and diaper into the support of soft drink. According to the data set, it is represented as 0.4 divided by 0.6 into 0.6, which is equal to 1.11. The association rule is very useful in analyzing the data sets, as you can see from the example quoted above. The data is collected using barcode scanners in supermarkets. Such databases consists of a large number of transaction records which list all items bought by a customer on a single purchase. So, the manager could know if certain groups of items are consistently purchased together and use this data for adjusting store layouts, cross-selling, promotions based on statistics. Benefits of market basket analysis are: analysis of market baskets can improve revenues and satisfaction of customers. Retailers can optimize product placement, offer unique deals and generate fresh product bundles to encourage further sales of these combinations by using information to determine that products are often bought together. What are the prerequisites for generating an association rule? Yes, there is a prerequisite. Usually, association rules are required to satisfy a minimum support specified by the user and at the minimum time a minimum confidence specified by the user. The generation of association rules is generally divided into two distinct steps. A minimum support threshold is implemented in order to find all common item sets in a database. Which determines strong association rule? Is there any possibility? Yes, the method of discovering trends, connections and correlations between sets of items in a database is nothing but the association rule mining, which is also determines a strong association rule mining. So, therefore, typically an association rule is called strong if it meets both a minimum support threshold and a minimum user confidence threshold. Now, I will conclude the association rule mining by saying that through this we have seen how data mining is helping us in making decisions that are advantageous for both customer and industries. We have also seen a simple explanation of a priori algorithm along with its implementation in R. It is not only used by the retail industry to provide us the discount on some bundles of products. The use cases of a priori algorithm stretches to Google's auto-completion feature and Amazon's recommendation systems. This module aims to make the reader familiar with the fundamentals of the algorithm and a general process followed to mine frequent item sets. Hope you're familiar now.